About 8 kilometers off Singapore's southern coast, there is a large green area sitting in the middle of the sea. And part of the surface you are looking at was created from waste. Yes, that's right, you heard correctly. In a country where every square meter of land matters, Singapore has found a very different way to deal with something that every city produces every single day: waste. Instead of using more land on shore for landfills, Singapore moved the problem out to sea. But the strange thing is, this place does not look like a landfill at all. There are no huge mountains of exposed waste stretching into the distance. Instead, there is solid ground, green vegetation, and beyond it, the open ocean. So how can Singapore move such a massive amount of waste out to sea and gradually turn part of the water into new land? And more importantly, how do they keep all of that material contained without turning the surrounding sea into a massive polluted zone? Let's take a closer look in today's video. And before we begin, don't forget to leave a like and give this video a boost, my friends. Now, let's get started. To understand why Singapore had to move part of its waste disposal system offshore, we first need to look at something the country has always been short of: land. Singapore is a small island nation, but its limited land area must provide space for housing, industry, ports, roads, and many other types of infrastructure. During the 1960s and 1970s, most of Singapore's solid waste was still sent to landfills on the mainland. But as the population and economy continued to grow, the amount of waste increased, while finding large enough sites for new landfills became more difficult. So from the late 1970s, Singapore began changing the way it handled waste. Instead of sending all waste directly to landfills, waste that could be burned was sent to waste-to-energy plants. The first plant began operating in 1979, and today Singapore has 4 waste-to-energy plants in operation. There, incineration does more than produce heat for generating electricity. More importantly, for a country with limited land, it can reduce the volume of waste by up to around 90%. But that does not mean the waste simply disappears. The process still leaves behind incineration ash, along with other types of waste that cannot be burned. All of this remaining material still needs somewhere to be disposed of. And eventually, Singapore was left with almost no suitable options on the mainland. The government now says there is no available land on mainland Singapore for building another landfill. So instead of searching for more space inside the city, Singapore began creating waste disposal space out at sea. In 1999, Semakau Landfill began operating, becoming Singapore's first offshore landfill. And today, it is also the country's only remaining landfill. But Semakau was not created by simply dumping waste into the ocean. To turn part of the sea into a place that could receive ash and waste for decades, engineers had to build an offshore landfill that was isolated from the surrounding sea. And to understand how that system works, we first need to follow what happens to the waste before it reaches Semakau. The journey of the final waste material to Semakau begins at Singapore's waste-to-energy plants. Waste that can be burned is sent into furnaces at temperatures of around 850 to 1000 degrees Celsius. The heat produced is used to generate electricity, while the volume of the waste is greatly reduced. But some material still remains: incineration ash, along with waste that cannot be burned. This is the material that still has to be sent to a landfill. It is transported to the Tuas Marine Transfer Station, TMTS, then loaded onto specialized barges and towed out to Semakau. From Tuas to the landfill, each journey covers about 33.3 kilometers across the sea. But transporting the waste offshore only solves part of the problem. The bigger challenge is, how do you build a landfill in a place that was originally open water? To do this, engineers built a perimeter bund about 7 kilometers long, enclosing the water between Pulau Semakau and Pulau Sekeng. This system encloses around 350 hectares of sea space and separates the landfill from the surrounding water. During the first phase, the enclosed area was divided into several landfill cells, allowing each section to be filled one at a time. But the bund only keeps the material in the right place. The next challenge is controlling leachate, contaminated water that forms when water comes into contact with ash and waste. So the inside of the Semakau bund is lined with an impermeable membrane and a layer of marine clay. These layers help keep the leachate inside the landfill and prevent it from escaping into the surrounding sea. Once the material reaches Semakau, it is transported to the landfill cells currently in use. In areas that are already shallow enough, the ash is deposited, spread, and compacted in layers, gradually raising the level of the landfill. But as the cells in the first phase began running out of space, Singapore had to move into phase 2. Before filling operations began, more than 700 coral colonies in the area were relocated, while fish inside the lagoon were moved out into the open sea. The engineering challenge was that the remaining area was still a large body of water with a deep and uneven seabed, making it impossible for normal landfill equipment to operate directly. To solve this problem, engineers used a floating platform about 200 meters long. From the platform, ash was deposited into the lower parts of the seabed, gradually raising and leveling the seafloor. This continued until the water depth was reduced to around 2 meters. At that point, normal landfill equipment could take over, spreading and compacting the material in layers. But as more material was added, more water inside the enclosed area was displaced. Together with rainwater, this excess water had to be treated before it could return to the sea. So Phase 2 uses a floating wastewater treatment system. The excess water is collected, treated to the required standard, and only then discharged back into the surrounding sea. After that, filling continues layer by layer. The level of the landfill gradually rises until areas that were once underwater finally reach ground level. Once a cell is completely filled, its surface is covered. Over time, grass and trees begin to grow on top. And that is why when you look at Semakau from above today, many areas barely look like a landfill at all. What was once open water has become a green surface in the middle of the sea. But that result also leads to Semakau's biggest limitation. Every part of the landfill that is filled means less remaining capacity. Incineration ash and non-incinerable waste continue to arrive here. And according to current projections, if the disposal rate does not fall significantly, Semakau could approach its capacity limit around 2035. This is the physical limit of a landfill with a finite amount of space. So Singapore now faces a new question. Can it reduce the amount of material sent to Semakau, or recover some of what has already been buried and use it again? That brings us to the next part of the story. First, the country wants to reduce the amount of waste that reaches Semakau in the first place. The Zero Waste Master Plan aims to reduce the amount of waste sent to landfill per person per day by 30% by 2030, compared with 2018 levels. But the more interesting engineering challenge is what to do with the material already inside the landfill. Singapore's National Environment Agency is studying ways to excavate, recover, and process material already buried at Semakau instead of leaving it there permanently. One possible use is to turn some of that recovered material into an alternative fill material for land reclamation. Singapore has also worked with the Maritime and Port Authority, the National University of Singapore, and other partners to study whether material recovered from Semakau could be used for Tuas Port Phase 3. This approach has been studied for feasibility, but it is not yet a process being used on a large scale. And in 2026, this direction was taken further with the launch of Treasures, a national research center focused on difficult waste streams. The research includes ways to process and reuse these residues for construction, coastal protection, and land reclamation. If these technologies prove practical, Some of the material once buried at Semakau could be recovered, processed, and used in new projects. And that could be Singapore's next step. Not simply finding another place to bury waste, but reducing the amount of material that reaches landfills, while finding ways to reuse what was once considered waste. That brings us to the end of today's video. Thank you for staying with us all the way to the end. If you enjoyed the video and found it useful, don't forget to leave a like and give this video a boost, my friends. For now, goodbye, and I'll see you again in the next video.